Hi, welcome back to Educator.com. Next we're going to talk about some more aromatic reactions that can happen. And so far the reaction we've seen is one called Electrophilic Aromatic Substitution. And it looks something like this. We start with benzene or some substituted benzene. And one of the hydrogens on that ring ends up getting replaced by an electrophile. And we end up attaching an electrophile onto the aromatic ring. We call that electrophilic aromatic substitutions. And we've seen a wide variety of electrophiles that can be introduced to an aromatic system this way. If you use Br2 FeBr3 or Cl2 FeCl3, that would be your way of forming Br plus or Cl plus. So we can brominate or chlorinate a benzene ring this way. HNO3, H2SO4 combined to form NO2 plus. We could do a nitration. SO3, H2SO4 is a way of adding a sulfonyl group, an SO3H group, a sulfonic group. And all of these various methods are ways of generating carbocations. If you have a carbocation, you could do a reaction called a Friedel-Crafts alkylation reaction, in which you add an alkyl group. So we could form a carbocation by protonating an alcohol with a Bronsted acid or a Lewis acid and causing water to leave, or use a Lewis acid to remove a leaving group, or protonate an alkene, so on. And if we were to take an acid chloride and aluminum trihalide, that can pluck off the chlorine and make an acyl cation called an acylium ion, and that reaction is called the Friedel-Crafts acylation. So we can add an acyl group or an alkyl group or a variety of these other substitutions. So we can use combinations of these electrophilic aromatic substitution reactions to make all sorts of interesting benzene rings and di-substituted benzene rings and so on. But there are a few other reactions we can do.